Welcome to everyone who is joining us at Kwaime's eMobility Days, our first virtual forum this year. My name is Bradley Smeaton and I'm the event director for Kwaime Berlin. Over the next 2 days, we are delighted to share exclusive research with you on EV component developments with IHS Markit, a coffee time chat on in-house versus outsourced automotive production in partnership with Audi, ZF Group and IHS. We'll also be running an interactive workshop on effective recycling techniques of battery packs and permanent magnets pioneered by the Fraunhofer Society. I would like to thank our community for supporting us over the last 12 months, and I'm sure you will find the content over the next 2 days thought-provoking and insightful. Please feel free to ask any questions and make these sessions as interactive as possible. I will leave you in the capable hands of Liam, who some of you might know from previous webinars. Take care and please enjoy Kwaime's eMobility Days.
Thank you, Brad, and good morning to all of you joining us this morning for the first session of Kwaime eMobility Days. Before I introduce our speaker for this morning, I'd quickly like to go through some general housekeeping rules for the webinar. It will last today for roughly 60 minutes, including 15 minutes for Q&A at the end of the session. You should all see a panel on the right-hand side of your screen with various tabs. If you've got a question that you'd like our speaker to answer, please use the question function in the panel and we'll get to them at the end of the presentation. The chat function as well will remain open throughout the session. Please feel free to use that for any additional comments, or if you have any technical issues, one of our members of the team will be with you to try and talk through any issues with you there. And on that note, I'd now like to introduce our speaker for today from IHS, who will be talking us through our upcoming white paper about global electric motor and alternative powertrain developments. So I'm joined this morning by Claudio Vittori, Senior Technical Research Analyst for Powertrain and eMobility Component Research at IHS Markit.
Thank you very much, Liam, for the introduction, and good morning to everyone also from my side. It has been a great pleasure for us to cooperate with all you guys with the CVM event on preparing this white paper and going through some interesting content about the developments of e-motor drive lines and related components. Within our presentation, we will go through some of the main contents as have been, let's say, further analyzed within the white paper. So I will encourage all of you to get access to the white paper and discovering all the details available there. Within our presentation, we will go through a brief introduction of IHS Markit as a company and of the role of IHS Markit within the automotive industry, passing through the alternative propulsion vehicle market with an historical view and the expected volumes for the years to come, and having a deep dive in terms of technological trends, as well as putting in comparison 4 of the main global OEMs in terms of supply chain dynamics, technological choices, and integration of the different components, drawing at the end some conclusions. So let me start with a brief introduction about IHS Markit. We are a company counting more or less 16,000 employees across the globe in more than 30 countries, and within our we are now celebrating. We celebrating in 2020 about 100 years of market intelligence, thanks to the pole historical position into the market, and our business is mainly refers to the business intelligence support. So we provide unique insight with strong regional dependency to all our customers, ranging from the different sectors, from chemicals to automotive to maritime and trade, and all the technological fields. Within the automotive industry, we do have about 1,000 employees, 1,000 experts working on a daily routine on providing information along the entire supply chain and manufacturing process about the automotive industry. As you do see from the slides, we do have a sort of hierarchy within the automotive industry, which allows all of our colleagues to work in a separate bunch of the automotive industry, providing unique insights. Today we are gonna through the components domain where I'm located, where I'm sitting on, And just for your understanding, all the components information that we can address today are based on all the intelligence made by our colleagues in terms of sales and production forecasts, which means how many vehicles we do expect into the next years, with an horizon until 12 years view. Having the support of our powertrain colleagues, providing all the information in terms of engine split, so if a vehicle will be pure internal combustion, as well as start and stop technology, going deeper in terms of what kind of electrification degree we will get in terms of mild hybrid, full hybrid, fuel cell, or pure electric vehicle. And then within our domain, which counts about 300 colleagues, we do cover all the components of spec in terms of for the automotive industry, covering the light vehicle passenger market until the 4 tons. And looking at the great picture, as a IHS market, we have the capability of including into all the steps of our analysis, all the efforts put in place by our colleagues in all the divisions. So within our forecast, as well as in terms of components, technological choice and technological adoption, as well as supply chain dynamics, we do take into consideration some of the main factors influencing the overall market, like the fuel price, the trade and commerce, the consumer preferences, the GDP forecast, and all the other information available within our structure. As I said, I'm part of the components domain, and within our team, we do map more than 130 components at a nameplate level. We are talking about more or less 13 different domains, and covering all the major components within a car. I'm of course referring to all the components in terms of internal combustion, as well as covering the whole range between internal combustion as well as pure electric vehicle technology. My team is mainly focusing to the e-mobility part, as you can see here, highlighted with the orange box. And within our daily routine, we do cover all the information concerning the electric motors technology, as well as the powertronics, which includes the inverter, DC-DC converter, onboard charger, and all the charging infrastructure, all the charging aspects into the vehicle side, charging connectors, onboard charger, and DC charging capability for all the vehicles. We do have all the battery-related topic, which is called energy storage device, which go through all the main aspects in terms of technological choices, as well as supply chain information, covering the single battery cells, battery modules, BMS, as well as the battery pack. We do have a separate modules, which is the charge infrastructure forecast, which is a unique view in terms of deployment and future forecasts in terms of charge infrastructure availability and deployment for the next years. Feel free to reach out if you have any doubt, or if you want to get more about our coverage in terms of data. Okay, let's get the presentation started, and let's get started from the technological point of view of the presentation. As I said, the main part refers to the global alternative propulsion market in terms of overall trend for the next few years. As we do see from the left side of the screen, the alternative propulsion vehicle market, which is represented by the electric ones, full hybrid, mild hybrid technology, counted today within an overall market of about 70 millions of light vehicle passenger market, counted in 2020 for a bit more than 10% of the overall market. And if we go along the years until 2030, we do appreciate how the penetration rate of alternative propulsion is expected to grow. I probably will say exponentially, getting by 2030 more or less 50-60% of the overall market share. market share. The interest point is probably the fact that internal combustion part, including in pure internal combustion as well as start and stop technology, will decrease the overall share, and all the alternative propulsion vehicles will displace the good presence of the internal combustion vehicles. So we do expect by 2030 about 100 million of light vehicle passenger market to be produced yearly. And as you do see, if we compare this curve with the one between 2010 and 2020, we can immediately appreciate how the mild hybrid technology will be probably one of the big winner of this electrification wave, probably thanks to the good compromise in terms of investments and CO2 reduction, which is something pretty new in terms of AP curve, AP wave, because looking back to 2000 until between the horizon of 2012 and 2020, the full hybrid technology has been probably the main driver of the market of alternative propulsion vehicle. The other major trend can refer to the electric propulsion, as we do see is expected to grow, and if compared with the full hybrid portion, is expected to be wider in terms of adoption rather than full hybrid and plug-in hybrid technology, getting getting more or less 15-20% of the overall market share of market by 2030. If we move into the right side, we can also appreciate how the deployment of alternative propulsion vehicle market in terms of production volumes will change across the different regions. And at the first glance, we do see how the penetration of electric vehicles, the pink portions within the graphs, will change widely according to the different regions, where the European market and the Chinese market will lead the way in terms of electric vehicles deployment, rather than US, where the internal combustion market in 2030 will be still mainly driven by internal combustion and start and stop technology. Going ahead, it's probably interesting to have a good comparison of the overall trend in terms of total production volumes between 2015 until 2023, as well as a good comparison in terms of internal combustion and start and stop versus alternative propulsion vehicle market. Of course, looking at 2020, we have a drop due to the coronavirus implications, with the volumes falling down from about 90 millions of vehicles in 2020 to less than 80 millions of vehicles by 2020 in terms of overall production volumes. It's interesting to make a comparison between, as I said, between start and stop, internal combustion and start and stop versus alternative propulsion, because after 2020, we do see how the internal combustion expectations are scaling down, are reducing the presence within the light vehicle propulsion market, and whether the alternative propulsion vehicle market, the alternative propulsion vehicles are still growing in terms of expected volumes until 2033. As a general trend, we do see the time between 2020 and 2023 as a sort of recovery mode, and we do not expect light vehicle passenger market coming back to the pre-COVID volumes until at least 2023 in terms of overall production volumes. Let's go into a bit more details in terms of technological choices and expected choices in terms of electric vehicles and alternative propulsion vehicles. The first point that has been raised into the presentation is the voltage architecture within all the vehicles, and we do have the chance of comparing two sections of the market here, with full hybrid and mild hybrid technology into the left side, as well as pure electric vehicle fuel cell technology into the right side. Immediately, we do see how the mild hybrid and full hybrid technology will be the market will be driven until 2030 by the low voltage system applications in terms of bigger penetration rate. And referring to the low voltage market, we are talking about mainly vehicles equipped with less than 60 volt as an overall architecture. Of course, within the section, the mild hybrid technology will probably will be more affected by low voltage system rather than all the hybrid ones. If we move into the right side, looking at the pure electric vehicle and fuel cell one, we do see how the market in these two sections will be mainly driven by medium voltage system, which is we are probably talking about a range between 400 volt until 650 volt. Of course, we do expect some pure electric vehicles that will be equipped with the ultra high voltage system, and which is referring to all the vehicles with a system voltage higher than 650 volt. That said, we do not expect this big advent in terms of 800 volt application over the next few years. Going ahead, the other point it's probably interesting is one of the other trends that is now emerging in terms of, especially for the inverter part, but overall in terms of the overall power electronics domain, is the switching device technology used in most of all the power electronics side. We, as IHS Markit, we do cover all the information regarding the switching technologies to be adopted within into the inverter type. And again, we can have a good comparison between full hybrid and mild hybrid technology into the left, as well as versus the pure electric vehicle and fuel cell technology into the right side. As we do see over the next few years, we do expect the market mainly driven by MOSFET technology in terms of switching technologies for full hybrid and mild hybrid. Of course, the MOSFET will be probably the main technology adopted over the next few years for the mild hybrid technology. IGBT will refer more to the full hybrid technology. We do expect by 2026 a sort of trend with more mild hybrid technology, probably equipped with IGBT in terms of technological step for the mild hybrid technology as well. Of course, as you do see here, new technologies are expected to come into the market into the long run between 2027 and 2030. I'm talking about silicon carbide and GaN applications. Of course, as we can see at the first glance, we do expect this technology coming first into, or let's say in a wider adoption into the pure electric vehicle and fuel cell technology rather than the hybrid ones. But we do expect few applications coming, especially for the high voltage application or full hybrid coming to the market as well into this section of the graph. Moving to the right side, as I said, the market is which is now mainly driven by IGBT. Is going to change probably into the last portion of the graph, with silicon carbide adoption growing, and we do expect this demand growing already in the next 2-3 years as a general demand, with some GaN applications coming to the market by 2027 until 2030. As we do see, we do have some silicon carbide application already today, but one of the main interesting example of silicon carbide application is Tesla Model 3, which is today now equipping the silicon carbide technology in terms of inverter solution. Going ahead, one of the other interesting point is probably the electric motor part. Having a good going along the years, we do see how the market is expected to grow exponentially over the next few years. The market is is counting today about 13 millions of electric motors produced annually by 2020. If we look at 2030, we do expect our overall market getting more 18 millions of e-motor to be produced annually, with a annual growth of about 19-20% over the next few years. In terms of technological adoptions, we do see immediately how, of course, several solutions are already available into the market, have been applied to all the vehicles, and we do see immediately how the permanent magnet solution are today and will remain over the next years the main adopted solutions. Of course, this will probably impact the full hybrid and pure electric vehicle technology, as well as some mild hybrid application for the surface mounted solution. The claw pole machines are also pretty interesting in terms of overall volumes. This is one of the main adopted solutions for the mild hybrid technology today, and expected to remain the same over the next few years for the mild hybrid technology. Another interesting point in terms of overall market is the integration level of the components. The integration level is one of the most interesting portion of our research now. Everyone is looking at the integration level as a sort of good solution, reducing the weight and the cost, and improving the synergies of multiple components within a car. In these slides, we are looking at the e-motor integration trend, and as we do see from the graph, we have a great distribution across all the domains. This comes from the fact that all the categories of vehicle are now included. So if we talk, for example, about motor inverter, this would be one of the preferred solution in terms of mild hybrid technology for example, the belt application, P0 application, where motor and inverter are typically integrated in more than 80-85% of the cases. The motor, inverter, and transmission, the 3-in-1, are expected to be the preferred solution for all the e-axle technology. But we will go deeper into the analysis of e-axle in the next few slides. Going ahead, we do the same in terms of power electronics. As I was mentioning before, the integration level will happen at the motor side, but we do expect the same across the board in terms of the overall vehicle. And as we do see immediately, the power electronics integration level will offer more fragmentation, more solution to be adopted by the OEMs according to the different platforms and general trend in terms of supply chain dynamics, as well as OEM solutions. So we do expect over the next few years great applications growing according to the different type of vehicle, as well as platform and OEM decision. Yeah, let's go. One of the most interesting part of the white paper is probably the comparison between four global OEMs. And within our analysis, we took into consideration Volkswagen, PSA Group, and the Stellantis Group now, Hyundai, Kia Motors, as well as Tesla, and having a sort of comparison within all the remaining OEMs. As we do see immediately, the four brands accounted for in 2020 for more than 40% of the overall electric motors market, and we do expect that the market is of course growing in terms of e-axle solutions, so reducing the scope to the e-axle to be applied to to full hybrid with rear e-axle solution, as well as to all the pure electric vehicle solutions. And we do expect the market growing from 3 million of electric motor for e-axle up to about 16 million of electric motors for e-axle to be produced by 2025. Of course, the market is expected to grow, and the four 4 brands will decrease the overall share of the market. We do expect that the 4 brands reaching about 6 million of electric motors to be produced on the axle side within the overall market of 16 millions of units by 2025. As I said, we are now referring to only to the pure to the e-axle solutions, and it's interesting to have a comparison between the technological choices made by the different OEMs. As we see at the first glance, most of the market refers to induction machines and permanent magnet solutions. We do have some axial flux technology, which is probably well known for the solution, because it's one of the solutions adopted for the Ferrari SF90 into the P1 application. We do expect over the next years few applications moving into the axial flux machine solution for the e-axle, especially within the Volkswagen group, but we do not expect a wider adoption or volumes getting out from a niche application. Comparing all the 4 brands, as I said, the PM solution as well as induction machines will remain the main driver, the main technological driver. Of course, we do have some applications like Hyundai Kia relying for most of the volumes into the PM solution, IPM solution with the dates, and which is expected to grow up to 1.2 million of electric motors for e-axle to be produced by 2025, and the same seems to be happening into the PSR group, into which is not including the FCA volumes now. It's just referring to the PSR, and the situation changes a bit if we move into the Volkswagen and Tesla application. Of course, most of the market will still refer to PM solutions for an overall market share of between 80 and 70% of the overall e-motor for e-axle. The reason of having industrial machines refers to the general approach of the 2 brands in terms of all-wheel drive pure electric vehicle applications. In this case, we do expect that the market will remain as it is now, with the rear-wheel drive or the highest motor, the highest e-axle, typically the rear one, will be equipped with the PM solutions, and all the front wheel drive or all the front e-axle application would be equipped with induction machines. Going ahead into the comparison, it's interesting to look at the inverter solutions comparison. Of course, again, we do have few brands. IGBTs in some cases is expected to remain the main technological driver, especially for PSR and for Volkswagen. The situation changes if we move into Hyundai, Kia, and Tesla. Of course, the Tesla volumes are now mainly driven by the Model 3, which is expected to remain over the next few years to be equipped with silicon carbide solution rather than IGBT ones. And we do expect, as we said into the previous part of the presentation, more volumes getting silicon carbide over the next 2-3 years rather than IGBT solutions. Another point of integration of comparison is the integration trend. As we have seen before, the integration is expected to grow over the next few years, and the e-axle are probably one of the main, let's say, machine where the integration will happen. In most of the cases, we do see a market still looking at the 3-in-1 solution, motor, inverter, and transmission combined in a single box. In a single integrated solution across the board, across all the major brands. In some cases, like the Volkswagen and for the MEB, we do have a solution where the motor and transmission are combined together, are integrated together with the inverter mounted into the tube. So which makes the solution basically 2-in-1 rather than a 3-in-1. But again, the general trend is, of course, to to get more integration rather than standalone solution over the next 2 years, and especially within the e-axle applications. Another interesting point is probably the supply chain dynamics, and of course, I mean, we do see how the situation is changing again over comparing the 4 brands. We do have some brands like Tesla, where the vertical integration has been always the main driver of the technological choice for everything. Despite the Tesla was referring to Delta for the inverter solution and for the DC-DC converter onboard charging, in the first wave of first generation of vehicles, they then moved in-house the production of the 2 components. So showing off what is the typical approach of Tesla as a vertical integrator across all the domains. And the situation changes again. I mean, for Hyundai, Kia, and PSA, most of the volumes are already made in-house. Of course, when we talk about PSA, yes, production is in-house, but of course, as a HS market, we do cover some third parties within our data, which are pretty useful to better define the market. That's the case, for example, of the PSA. As I said, the PSA volumes are now produced now, but thanks to the cooperation with the design part, which is called by us by design parent, so a sort of third party, third supplier, which is now offering the technological information and background and support to PSA for producing in-house the electric motors. By 2022, as we do see these few volumes which are which are still made in outsourcing will decrease due to the Nidec PSA joint venture starting the production of the electric motors, and of course affecting mainly the e-axle solutions. Probably one of the interesting point is the Volkswagen approach. Of course, as we do see, the outsourcing is now massively a presence within the Volkswagen overall business. Of course, the graph might mislead, because if we go farther into the horizon with a view until 2030, the in-house production is expected to grow and rapidly, rather than what we can see now into the graph. Of course, the cooperation with the tier 1 supply, with some specific tier 1 supplier, are expected to remain in place for the next few years into the major platform of Volkswagen. In terms of logistics, we do see all the brands, one of the preferred solution for all the brands is to rely on a region-to-region solution as much as possible. The situation changes probably a bit with Tesla and Hyundai Kia, just for the strong presence of the 2 brands in certain regions rather than in others. Okay, let's try to wrap up with a few conclusions according to the slides above. Of course, the alternative propulsion vehicle market have been, or the electric vehicles program overall, have been relatively low volume to date. But of course, as we have seen, the overall alternative propulsion and the pure electric vehicle technology are expected to grow fast into the next, and getting more market share by 2030. And we do expect that in the next few years, this increased volume of productions will probably drive towards a consolidation on fewer and bigger electric vehicle platforms, like the Volkswagen MEB. More brands using less different platforms, optimizing the cost, investments, and the technological choices. The second point refers to the integration. As I said, the overall trend across all the domains, but of course with a special focus on the e-axle. In this, we do expect that in the next few years, across all the domains, but with a special focus on the axle, the integration level will grow, and this is expected to have an impact in terms of the supply chain, because more integration will reduce the brief of the supply chain, having the OEMs relying more in certain suppliers over the next few years. On the technology front, as we said, we do expect new technologies coming to the market with the intent of reducing, on putting more efficiency into the overall vehicle in terms of charging aspects, as well as in reducing the losses. And the switching devices are probably one of the most interesting portion of this evolution in terms of technology front. And within the inverter production, we do expect the silicon carbide applications growing over the next few years. 2022, 2023 are probably the 2 years where we do expect a sort of step into the silicon carbide application for the inverter part. Of course, IGBT will remain to the market and covering, especially outside the purity vehicle technology, covering most of the market. In terms of e-motor, and with a special focus on the axle part, despite other technologies are coming to the market, as we said, the axle flux machine or the current excited solution adopted by BMW are coming to the market, are going to be adopted by several OEMs. We do not expect a big change in terms of technological choice. PM machines are expected to remain into the market and getting 70-80% of the overall market, especially when talking about e-axle solutions. The last point is about the OEM in-house versus outsourcing production. There will be a good discussion today within our panel discussion in the afternoon. So I will encourage all of you guys to join the discussion. We will get the few feedbacks from the OEM side and tier one supplier side. But as a IHS market, we do expect over the next few years that the OEMs are probably growing in terms of production in-house rather than outsourcing, with a sort of first phase passing through the license agreement that some OEMs are adopting or are doing with some tier ones into the e-motor and e-motor for e-axle production. Thank you very much for your attention. I'm happy to answer to all the questions that can come.
Thank you, Claudio. Very comprehensive as always. We have actually had a good amount of questions come through. I'll wait for you to come back on. Perfect. So yeah, we've had a good amount of questions come through. Anyone else that has still got questions to ask, we do have another 20-25 minutes. So if you have another question that's not already been published, please do ask those now. You can also upvote with the thumbs up button the questions that you most like answered. We will go through these one by one. My colleague as well will also be posting Claudio's contact details in the chat for you shortly. So if there is anything you'd like to follow up with Claudio after this session is finished, please feel free to do so. So moving on to the questions. So the first question that we have through comes in from Wolfgang Werner, and I think it goes back to the beginning of the presentation when we're looking at the sort of the overall market trends. So he's mentioning with OEMs stopping to produce ICE vehicles by 2030, 2035, that the outlook seemed maybe a little bit too maybe not enough in favor of electric vehicle components. I don't know if you have a comment on that, Claudio.
Yeah, I mean, all the expected volumes in terms of internal combustion, alternative propulsion are coming from my colleagues. So what I can say from my side is, of course, we do expect internal combustion start-to-stop technology remaining into the market. Of course, as we have seen, the alternative propulsion wave will displace most of these production volumes, but we do not expect by 2030 a sort of general revolution of alternative propulsion vehicles becoming the leader of the light vehicle passenger market over the next few years. Of course, if we look at the let's say vehicle with charging capability, if you like. And if you pay attention to the graph, we do see how the pure electric vehicle technology is expected to be the main player within this subsection, and this is driven by several reasons. One of them, the most interesting one, is the efficiency of the vehicles versus the general overall investments and weights and let's say complex point that have to be carried on within the plug-in one or the overall hybrid technology.
Thank you very much. The next question we have comes through from Miguel Castro Frenzel, and he has asked, how do you see the market growth and annual volume for continuous hairpin stators?
Well, within our components demand, we do not step down into the, let's say, let's call subcomponents. So what we do map is the supply chain and technological choice in terms of the overall market, the overall motors. So all the categories have been defined accordingly to the slides that we have seen. Of course, we do have good discussion with many tier 2, because these are all the things that are helping out to define the overall trend of the two technologies. So I cannot probably have a good figures in terms of forecast. I would be happy to have a separate chat if on the topic on that, but I have no official data or figures to be let's say delivered here.
Okay, thank you very much. Next question we have is, I think, just asking for a clarification of the low, medium, and high voltage. So the question specifically says, what is the regime of low, medium, and high voltage that you mean that you were covering earlier on?
Yeah, the low voltage, I mean, if you go into the white paper, there will be a good explanation of all the categories. So yeah, I encourage you to go through the list and having further details there. In generally speaking, the low voltage applications are all the applications that are referring to the below 60 volts. And then we have the categories ranging from 60 volt to 400 volts, and then two other categories ranging from 400 to 150 volt, and then all the applications above the 650 volts.
Perfect, thank you. The next question we have is from Tim Schmidt, and he asks, which role do you think will the wheel hub motor play in the future of e-motors? And do you think this technology will keep their niche or may gain importance in the future and will be produced in mass volume?
Yeah, great. Thanks for the question. Very interesting. Yeah, well, let's say don't forget we are still talking about light vehicle passenger market, and within this portion of the market, we do not expect many vehicles coming with these solutions. Of course, we have some of them for the low storm application, for example, one which is included in our data, as well as some other brands. We do not expect a wide adoption of this technology. We are still talking about some thousands or a few millions of vehicles over the next years. That's the reason why this technology is not really good presence within our data. The situation changes if we move into other section of the data which is not covered by our components domain, light duty vehicles. We do expect probably more applications there.
Okay, thank you. Another question from Himanshu Bhatt, and they ask, how do you foresee the use of EESM motors in the years to come? As Nissan is adopting this type of electric motor going ahead, are there any other OEMs going to adopt this technology?
Yeah, well, yes. I mean, the definition of the electric motors is always tricky. We do have to, let's say, accumulate some of the categories within our data. Of course, we do have some volumes there. In general, we do not forecast this technology to be more adopted than all the categories mentioned within the data. Which was the other question? Sorry.
So the follow-up to how do you foresee the use of EESM motors in the years to come was Nissan is adopting that technology. So they're asking, are there any other OEMs that will be adopting it as well?
Well, I will encourage you to get in touch with me. Maybe we can go through the data. I don't remember now other applications, frankly speaking. But I will be happy to follow up and looking at our data to, let's say, perfectly answer to your question.
Thank you, Claudio. And again, the contact details for Claudio, I'll have a colleague post those in the chat for you again. So if people would like to follow up to any of these topics, they can do so. Moving on to the next question, a question from Wolfensteiner, and he asks, what is your definition of a mild hybrid?
Yeah, good question. I mean, again, this is something that comes from our colleagues. It's for our team in terms of component domain, a sort of input. In general, I can briefly tell you the official definition of IHS market about a mild hybrid. We are talking about there is no direct connection with the voltage. It's mainly related to the absence of electric vehicles range. But I will be happy again to follow up with the perfect definition. Yeah, just to be sure on that.
Okay, thank you. Another question in, which is asking, for which application do you forecast SPM at VW and why SPM?
Okay, another challenging question. I mean, as you can imagine, we have really a lot of application within Volkswagen Group, so it's not a matter of escaping from the question. But please reach me out separately, and we can go through the data and can provide you maybe a few applications or specific programs where we do foresee this application. And the reason of why, of course, refers back to the kind of vehicles that we are forecasting.
Thank you. Another question through. Okay, so there's a question that was accidentally deleted from Carsten. Asks, is there a future to switched reluctance? Other papers predict a good future for this type of e-motor.
Well, again, it depends on the categories. We do expect that the current excited machines probably more adopted in the next future, rather than the switching reluctance. In general, we do not expect big trends towards this technology.
Okay, thank you. We have another question through to do with axial flux. So the question is, why is axial flux so low in adoption numbers despite the high power density and lower BOM versus torque or power?
Yeah, the reason is basically because the PM machines are forecasted to remain the main adoption. I'm not sure if he's referring to the axle part of the overall or I think it's not mentioned, right? In general, okay. In general, we do not forecast wide application of axial flux machines into the axle, just because the PM solution is probably the most adopted one. And again, I mean, probably this is a good question for all the players sitting at the table this afternoon. From our perspective, we do not expect, especially within the e-axle solution, a wider adoption. Of course, there will be some solution adopted the axial flux. We do expect probably some premium, more sportive brands maybe working in this sense. But as an overall market, I mean, the numbers of the axial flux machine are not expected to become massively important within the data.
Okay, thank you. We've got plenty more questions coming in, actually, which is great. Thank you, everyone, for your engagement. And the next one comes from Hassan, who asks, currently fuel cell electric vehicles occupy a tiny amount of EV share as compared to BEVs and PHEVs. In the future, do you expect the share of fuel cell EVs in annual additions to increase?
Well, good question. Thanks. I mean, frankly speaking, this is a sort of common question from our side. I mean, again, this refers to our production and sales colleagues. But despite that, I think I can answer that no, we do not forecast within the light vehicle passenger market a big adoption of fuel cell technologies. Not comparable with all the volumes that we have seen for plug-in and pure electric vehicle technology. Of course, we're still talking about light vehicle passenger market.
Mm-hmm. Thank you. We have a question here, which is, can you give a forecast for 800-volt motors?
Yeah, good, thanks. Well, this refers back to the overall voltage architecture of vehicles. As we have seen from the graphs, we do not, our colleagues, well, not us, are not expecting the 800 volt coming to the market massively as advertised, let's say, or as expected. Of course, we do update our data on a regular base, on a monthly base. We do work with all the suppliers, all the OEMs on a daily base. So we do have the 800 volt as one of the special focus, but for the time being, the 800 volt application overall in terms of general architecture as well as motors are not expected to be, let's say, really massive within the data.
Perfect, thank you. We have some more questions coming in. The next one from Matteo, who's asking hairpin or round wire technology for EV motors. So I think quite an open-ended question there. But I presume he'd be asking what would be the primary technology going forward.
Yeah, again, this steps down to the, let's say, a second level of the supply chain and technology. So we do not cover the two points. I think it's really a good question, and we are working to the background on probably getting more into this, let's say, second level of technology of choice. I would be happy to get in touch and see whether this answer can be somehow answered, or where we can give a support without our data, let's say, as our general understanding.
Thank you. The next question coming through, and again, this may be one that you're not able to answer, but why is there no more growth of no rare earth magnet e-machines due to the future LCA legislation focus?
Yeah, well, it's a good question. I mean, of course, I mean, all our forecasts are based on our intelligence and on our, let's say, our regular discussion, as I said. So the reason of having so much PM solutions into the market comes from the technological choices of all the OEM, of the main tier suppliers, as well as the OEMs once the motor are made now. So I mean, matching the expected volumes of the tier suppliers as well as the OEMs with the technological choice adopted. I mean, we do not forecast the PM solution stepping down or getting out from the major player of the market. Of course, the rare earth material is something that we keep an eye on that, and we do have our materials and chemicals colleagues working into the other side of the coin, and we do have a regular discussion with them as well. Just trying to connecting the dots from two perspectives to see whether these PM solutions expected to be feasible from a materials point of view.
Thank you again. We have another question from Enzo Caroni, who asks, did you compare your 5 years old forecast with your current one? And what has changed mostly? So over the past 5 years, what has developed in the most significant way?
Let's say, I'm not sure if you're talking about components or volumes. Let's say in general, for the future volumes, yes, we do have an yearly review in terms of volumes. Of course, this is outside my business, of my domain, my area of business. It's more into the production and sales. I know that they used to get a sort of quality check in terms of our core forecast in terms of the previous years versus the realized one. Of course, some facts like the coronavirus cannot be taken into consideration somehow, but in general, we do have a good reliability results in terms of general forecast or in terms of volumes. For the into the components domain, of course, the situation gets harder because we do not have any chance of mapping the comparison. Of course, we have changes. Typically, we do not have changes coming massively months versus months. It's something, if you compare probably years versus years, yes, we can have a different view, but of course, a lot of factors are probably influencing the technological choice as well as the supply chain. Yeah, it depends on let's say, just to briefly answer, it depends on the domain and the you know, the contents that object of the question.
Thank you. So we have another question here from Vincent, who asks, what is the trend of power and speed ratings for traction motors and BEVs?
Okay, good question. Thanks. I mean, I assume we are probably talking about high power applications for the axle section. In terms of speed, we are now looking at a sort of trend on higher speed coming to the market. 20,000 RPM are one of the solutions that we do expect growing into the next few years. I mean, if you want to reach out, I can share with you some general figures, but in principle, we do expect a market which is now, let's say, under or below 1% of applications for 20,000 RPM plus, growing of a few figures into the next few years until 2030. So a general trend towards higher speed is expected.
Perfect. We have a question from Michael Metz, which we may have already covered actually in one of the answers for previous questions. But he was asking, as he missed a section of the presentation, whether or not there was a mention about the development of fuel cell vehicles, which I think you have touched on briefly. Michael, in the chat, if you just let us know if you feel like the question has been answered. If not, we can return to the topic. So another question from Ali Elzain is, did you consider for Europe the EU7 emission and not only CO2 in your market outlook?
Yeah, of course. I mean, again, this falls under our colleagues in terms of production and sales. Of course, all the normatives are taken into consideration, and we do have our specialists covering the topic. So, if you want to have a direct connection with someone sitting in the team, I will be happy to create a connection, and then you can have all the details that you need.
Perfect, thank you. And I do notice, I'm looking through the questions here, that we actually have quite a few questions coming through about the future of in-house versus outsourced production. This is a topic we will be actually covering, and I will provide details for this at the end of this presentation later on today in a panel that we'll be running. So we won't go through the answers for these questions in detail, but what I will do is I can transfer these questions over. Claudio will also be a part of that panel later on today, and we can get through those topics in a lot more detail in that setting. If you've registered for the e-mobility days, I believe all the details should have been shared with you for the session this afternoon. So you should already be registered, and that's running from 3 till 4 CET this afternoon. But I'll come back to that in more detail at the end of the presentation. The next question, and I think we've got time for maybe one or two more here before we wrap up, is from Simon, who asked, do you think the technology choices and the level of integration show how much an OEM is committed to e-mobility? It looks like VW is not 100% committed compared to HK or PSA, and I'm not sure if you can answer that question from a sort of a neutral standpoint, but if you can, over to you.
Yeah. Frankly speaking, I don't think that there is a direct connection with the integration level and technology choice to the commitment toward e-mobility. I mean, just a matter of selecting one solution rather than the other one. The commitment, of course, is something that comes out from our expected volumes. And so comparing the overall volumes, you can see how the real commitment is in place or not. Of course, which is driven by the OEM's announcement. Our colleagues are taking into consideration the OEM's announcement, but of course, not only the OEM's announcement, but as well as all the normatives that, as I said before, and together with all the other aspects that I was showing into the beginning of the presentation.
Perfect. And I think, yeah, we'll do two more questions as we've got a couple of minutes left here. So we have a question from Marjan, who asks, what are the reasons that medium voltage level is focused in the future from OEMs? Are there different trends between BEV and FCEV?
What is it? Well, yeah, I mean, it's not easy to answer because we should go through some the details of the slides. This was like a general trend, and we just combined the fuel cell and pure electric vehicles. It's probably important to be reminded fuel cell technology adoption is not expected to be so high. So most of the vehicles, most of the applications we have seen there are probably referring to the pure electric vehicles rather than fuel cell. But if you have a specific question, I mean, I'm happy to try to answer it in going through the data.
Yeah, thank you. I'm just scrolling through the rest of the questions here for one final one. So we have a question from Simon Swallow, who's asking, as the circular economy and sustainability of components becomes more important, can you see the trends presented changing and being influenced by these factors?
Yeah, I mean, in terms of components, we are not mapping the CO2 footprint of the components, supply chain, logistics, and so on, not within the data now. Of course, this is a kind of exercise that we are doing separately, because in time we do see the CO2 footprint of the components and the logistic routes as one of the interesting points to be taken into consideration from the OEM's perspective. So I would say the answer is partially yes, we do have a view. We do not have any specific information within our data.
Okay, thank you. And for the interest of time, we've gone through, I think, quite a great number of questions. So thank you, Claudio, firstly, for answering all of these and for the presentation. Just as a follow-up, so Claudio has agreed for any of the questions that we haven't had time to get round to, we will be sharing those with him after this session, and we will put out the answers to those questions for you in a few days when we release the white paper and also the recording of this session. But for the session today, I just want to say thank you again, Claudio, for the great presentation and for the Q&A. Thank you to everyone that is tuned in for your engagement, especially with the questions. It's great to see so much involvement from the audience. Just to recap as well, that the full white paper in collaboration with IHS, of which Claudio was one of the authors, will be available to download on Thursday this week. There will be a link on our website and an on-demand email in your inbox that will all come through on Thursday. So that will give you access to the full report, all of the information that's been covered today, as well as a bit more information in there as well. The webinar itself is also going to be available to view again as a recording. This will also be available on the Thursday. So finally, to draw an end to this session, I just want to thank everyone once again for joining us and remind you that the next session is a panel discussion between Audi, IHS Markit with Claudio, ZF Group and Hitachi on in-house versus outsourced production of EV components. From the volume of questions we've had on this topic today, I would hope to see you there later on. I will transfer those questions over to that discussion, so we will get round to those later on today. The session's running from 3 till 4 CET. I hope to see you all there. Have a great day, everyone, and thanks again to Claudio.
Thank you too. Thank you all.
Thank you, everyone. Have a great day.
Bye-bye.